So we had a question on 2430 which asks which of these dienes would react the fastest. Remember, when we're looking at the dienes, generally we're trying to elevate the electrons that are in the HOMO to a higher energy, and that will allow us to react more readily with the LUMO. Anything that adds more electron density into the diene then is able to increase the energy of the HOMO and make it more reactive. So for example, in Q, we can add electron density through resonance, having extra electron density here, or having the resonance push electron density to an increased amount over here. In both of those cases, that increases the reactivity of Q, and so this is going to be faster than whether if we had just a straight diene, butadiene. S is not butadiene, it has an additional propyl group. It's going to be slightly activating because we can donate electron density back in through hyperconjugation. So hyperconjugation is a much weaker type of interaction than an actual resonance structure. And so this hyperconjugation is going to activate this, but it won't activate it nearly as much as Q. R looks like it might be very similar, but because we're separated out by this carbon, these electrons can't hop all the way over into the pi bond system. These electrons are isolated. Now we just have an electronegative atom that's going to draw electron density towards it in a dipole. That causes electron density to be pulled towards this carbon as well, more than it normally would. This is an electron withdrawing group and actually deactivates. So this is going to be much more active. This is going to be the second most, or the middle. And this one, R, is going to be the least active, because it actually withdraws electrons from the system rather than adds electrons into the system.